Hi guys, welcome to this tutorial video, and today we are going to look at how to sketch a cubic function. Basically we'll be looking at graphs in the form of f of x, which is equals to ax cubed plus bx squared plus cx plus d. The highest power is 3, hence we call this one a cubic function. So we'll first go through the basics as to what we need in order to sketch this graph. The first important thing that we need is the sign of A. The sign of A is the one which tells us how the graph will look or how it's shaped. If A is greater than 0, we have that our function is increasing. How does it increase? It takes this form of a shape now, which is wavy like. Now if we were to sketch our axis there and then base our focus on the first quadrant, we can see that as x keeps on getting more bigger, even y keeps on getting more bigger. So x and y increase together, or y increase with an increase in x, and this is an increasing cubic function. Now if a is less than 0, now this is where we get a decreasing function. Now when it decreases, it takes this shape now, which is something like that, the opposite of that. Again, if we construct our axis and then we base our focus on what happens here on the fourth quadrant now, we can see that as x keeps on approaching positive infinity, y keeps on going to negative infinity. So x increases with a decrease in y. So one variable increases whereas the other one decreases. Right, so that's how you will get the shape of the graph. And then secondly, now just like any other graph, you will need the intercepts, both intercepts. You will need the x-intercept. Remember, in order to get the x-intercept, what do? You let y equals to 0, and then in order to get the y-intercept, you then let x equals to 0, right? So these are the things that you need, and you will see a different or a special way of solving this one, since it's a cubic function, of solving the x-intercept. We'll get to that shortly. The other thing that you need are the stationary points. Stationary points, also known as the local turning points. Right, these are also known as the local turning points. As you can see there, where we're talking about the sign of A, here it looks like a turning point. In fact, it looks like a parabolic function that went like that and then it turned. All of a sudden again it turned. So it has two local turning points. One which we'll call a local maxima. That's the local maximum. A local maxima because it's a slight maximum point. The graph gets to that point, it turns, then it comes back to break that point. So it's local because it gets broken sometime when the graph increases further to the right. And this one is known as the local minimum because that point is not the absolute minimum. At some point the graph will come back and break that point, right? So we have a local maxima and we have a local minimum. And then from here, in order to find this, you should differentiate your function, your cubic function, with respect to x and equate to 0. Then you solve for the x values. Let's say now after solving for x, you get a value which is x is equals to a and x is equals to b. You will then take these values and substitute back to the original equation, whereby you will find f of a, which is equals to ax cubed plus bx, all that. You just substitute a on which equation? A on that equation, same as b. And then thirdly, what you need is the point of inflection. So you need the point of inflection. Basically what happens at the point of inflection, the graph changes concavity, right? Let's say it was concave down, then it's starting to be concave up. So that point right there, which connects the two parabolic parts, this one and the other one, this is known as the point of inflection. And in order for you to get that point, you will take the function of x, the cubic function, and differentiate it for the second time. Then you equate to 0. It will give you the x coordinate, and then you will take that coordinate, let's call it c. Let's say you get x is equals to c. You will then go back to the original function and find f of c, right? So that's everything you need. First of all, you need the sign of a, whether it's increasing or decreasing. If it increases, it takes that form. If it decreases, it takes that form. You will need the intercept, your x-intercept by letting y equals to 0, and your y-intercept by letting x equals to 0. You then need your stationary points, which we said are the local turning points, right? Is where the graph turns and eventually comes back to break that point. You will need your local maxima and your local minimum. Okay, so right here I have the summary version. It says the rules for sketching the cubic functions or the cubic graphs. First of all, you need what? You need the the y-intercept by letting x equals to 0, and you solve for y. You need the x-intercept by letting y equals to 0, and you solve for x. Spoke about the stationary points. We said you should differentiate the function, the original function, for the first time, and then you equate to 0, then you solve for x. Then you substitute the x values that you will get back to the original equation. It's important for you to do that. Do not substitute at the derived equation. It says if the function has two stationary points, establish whether they are a maximum or a minimum turning points by referring to the shape. Okay, yeah, you can do this, but usually I don't, because the graph tells me like which point is which. And from there you have the points of inflection. It says if the cubic function has only one stationary point, a lot of information that you don't need. But for points of inflection that are not stationary points, find the second derivative, right, and equate to 0, then solve for x. Remember, after solving for x, take the value of x that you get and substitute it back to the original equation, not the second derivative. Okay, so now let us go ahead and sketch one graph. Given this graph right here, f of x is equals to x cubed minus 2x squared minus 4x plus 8. First of all, we said we are going to comment on the sign of a. So as you can see, the sign of a is a 1, is the coefficient of x cubed. So the sign of a is greater than 0. And since the sign of a is greater than 0, we are expecting the graph to take that shape right there, which is an increasing function. And then secondly, we spoke about the intercept. So let us start with the y-intercept. For the y-intercept, remember that we should let the other variable, which is x, equals to 0. So in this case, we then have y, which is equals to 0 cubed minus 2 into 0 squared minus 4 into 0 plus 8. So you can see that it gives us an 8. In coordinate form, we have a 0 is to 8. And then now we are looking for the x-intercept. For the x-intercept now, remember you let the other variable, which is y, equals to 0. Let y equals to 0. When you let y equals to 0, you then have x cubed minus 2x squared minus 4x plus 8, which is equals to 0. Now it's very tricky to deal with this. You should substitute values of x such that they will make the right hand side equals to 0. Normally when I do this, I substitute values of x from, it's usually my x values don't go below -3 and they don't go beyond +3. What I mean is, first I will substitute a -3 there. I will say -3 all cubed minus 2 into -3 all squared minus 4x plus 8, which is equals to, let's see what that gives us. And then this gives us a -25. So -3 definitely won't be a solution to that equation. Then we shift to the next one. Let's take -2. We'll then say -2 cubed minus 2 into minus 2 squared minus 4 into minus 2 plus 8, which is equals to, oh, I forgot to put the -3 there, but I did so in my calculator. It's fine. And this gives me a 0 now. This gives me a 0, which means that one of the solutions of that equation, because it has 3 roots now, there's 3 values of x. One of those is when x is equals to -2. So this one is called a root. You can reverse this such that you write it as a factor by transposing the -2. It becomes x plus 2, which is equals to 0. So the x plus 2 is what? The x plus 2 is a factor, right? So now we are going to use that root there through a method called the synthesis method. So we'll use what we call the synthesis method. The synthesis simply tells you that you draw what looks like an L. It's more like a simplified version of the long division. And then you take the coefficients of all those terms right there. The coefficient of x cubed is 1. The coefficient of x squared is minus 2. The coefficient of x is negative 4. And then the coefficient, oh, that one's just a constant, which is a plus 8. Then you put the root, which is negative 2, here. First rule is just bring down the first coefficient, which is 1. And then you take the negative 2, you multiply by the 1, it gives you a negative 2. Then you add, you write it on top of the next term, right? So it's negative 2 times 1 gives you a negative 2. You write it on top of the next term. Then it becomes negative 2 plus negative 2. So you are going to add those two, which gives you a negative 4. And then from there, you're going to say negative 2 times negative 4, which gives you a positive 8 now. And then you add. Remember, after multiplying, you write it on top of the next term. 8 plus negative 4, which is positive 4. And then from there, you're going to say negative 2 times positive 4, which is negative 8. And then you add negative 8 plus positive 8, which is a 0. It should always give you a 0. If this is not a 0, then it means the root that you have there is incorrect. So now we can take this information right here and come up with something like, remember, we can rewrite this and take it from the root form to the factor form. As a factor, it becomes x plus 2, which will then multiply. Now this is no longer a cubic function, but now it represents the coefficients of the quadratic. Remember, a quadratic is f of x, which is ax squared plus bx plus c. So the coefficient of x squared is 1, so we have x squared. The coefficient of x becomes minus 4x. The coefficient, no, this is just the constant, which is the last term, plus 4, which is equals to 0. And if you can expand this, indeed it will take you back to the original function, which is what you have. So remember that math says x plus 2 is equals to 0, or the x squared minus 4x plus 4 should be the one which is 0. Then we already know that this is x is equals to negative 2. But this, when we try to factorize this, we have two brackets there. The factors of 4, which is what? Which is 2 and 2. The signs must be the same, both negative. So it's minus and minus, which is equals to 0. Then from here, we have that x minus 2 all squared is equals to 0. Then we square root both sides. So we have x, which is equals to positive 2. So it only has two x-intercept. One at minus 2 is to 0. And the other one at what? At positive 2 is to 0. Right? We then move on. From there, what are we looking for? We are looking for the stationary points. We will go and look for the stationary points. We said for the stationary points, what should we do? We should differentiate for the first time and equate to 0. So stationary points, the local maximum and the local minimum. And remember that our graph is f of x is equals to x cubed minus 2x squared minus 4x plus 8. So this then gives you what? It gives you that when you differentiate for the first time and equate to 0, you are going to use the power rule. So power rule tells you that for any x to the exponent n, f of x equals to x to the exponent n. F prime of x is equals to what? Is equals to n. You bring this to the front, then x to the exponent n minus 1. So same thing. Here you are going to have a 3 brought to the front, x to the exponent 3 minus 1, which is 2, minus. You bring the 2 here, it becomes 2 times 2, so it's minus 4x, then 2 minus 1, which is just 1. Then you bring the 1 here, it becomes a minus 4 still, then 1 minus 1, which is 0. Then the derivative of a constant is 0. So that's what you have now. Now you need to solve this and find the corresponding values of x. So if I try this and say I have a 3x on this bracket and on the other one I have an x, if I put a 2 here and I put a 2, it becomes 6 minus 2, which is 4. Yes, the signs must not be the same. The bigger one takes the sign in the middle. I'm choosing this one. Then it's plus, which is equals to 0. Or you could have used the quadratic, which is going to save you some time, maybe. And then from here, we can see that our x is then equals to negative 2 over 3, or x will be equals to positive 2. Now remember that these x values must correspond to certain y values. So you take them back, you substitute back to the original equation. So you should go and look for f of minus 2 over 3 by substituting what becomes minus 2 divided by 3 all cubed minus 2 into minus 2 over 3 squared minus 4 into minus 2 over 3 plus 8, right? So then this will give you a 256 over 27. Now in coordinate form, you have your x, which is minus 2 over 3, then your y, which is 256 divided by 27. You are going to do the same thing for f of 2 now. F of 2, but we already have 2 there. When you substitute 2, f of 2 will be none other than a 0. So it's 2 to the 3 minus 2 into 2 squared minus 4 into 2 plus 8. And we've seen that it's also an x-intercept. So the y is 0, then you have a 2 is 0, 2 is to 0. So one of these points, one of these local turning points is also an x-intercept, and it's this one. Then we said we are also going to look for the point of inflection now. Remember, for the point of inflection, we said we are going to derive for the second time and equate to 0. So for the point of inflection, what do we have? Point of inflection, we have f double prime of x, which is equals to 0. There's the first derivative. So now the second derivative will become 6x minus 4, which is equals to 0. Then x becomes 4 divided by 6, which is then 2 over 3. So we are going to substitute now. We are going to look for f of 2 over 3 in order to find the y coordinate that corresponds to this. Back to the original equation again, so that this thing becomes 2 over 3 cubed minus 2 into 2 over 3 squared minus 4 into 2 over 3, then plus 8. Then this thing should give you what? So this gives you a 128 divided by 27. In coordinate form, we have 2 over 3, which is the x coordinate, is to 128 divided by 27. So now we should take this information and sketch our graph without even stressing ourselves. Whenever you sketch a cubic function, first sketch the graph first. Do not sketch the axis. Start with the graph itself, the shape of the graph, how it looks. I know that the sign of A is positive, so the graph, I said, is going to do something like this. Right, since the sign of A is positive, the graph takes this shape. The graph should take a shape that looks something like that, right? And then from there we'll go to our intercept. Our intercept, remember that this one is the one which is also a turning point. So this is an x-intercept and also a turning point at the same time. This is just an x-intercept. Now think about it. There's only two ways in which we can draw our axis, our x-axis, because those are the most important one first, right? So this is what we'll do. We only have two x-intercepts, remember. One at positive 2, the other at negative 2. So if I draw it here and say those are my axes, look at it now, what it becomes. It says that, remember, this should then be negative 2 and that be positive 2. But if you think about it, positive 2 is the one which is also a turning point, not negative 2. So we'll switch our axes and say, what if we draw them below? Because we can either draw them here or draw them there. That's the only way we can have two x-intercepts in this graph. So if we have our axis here, and by default this will then become a minus 2 and this will become a positive 2. And now it's both an x-intercept and a turning point. And then from there we do our number line. You remember the number line says if this is minus 2, somewhere here we have minus 1, somewhere here we have a 0. In fact, the midpoint between these two things, right? Okay, so by default I can estimate and say, even if I'm counting from here, I have 1 here, somewhere here I have a 0, then I'll say my y-axis should be somewhere here. Those are my y's, because somewhere here I have a 1, somewhere here maybe I'll have a negative 1, right? Remember, it's just a sketch. Remember, the x-intercept is positive 8, so there I have an 8. And then I go, I check my I go and look at my stationary points. Remember that one of the stationary points is at 2 is to 0, so that one is already accommodated. But what does the other one? The other one was minus 2 over 3. So minus 2 over 3 can be that point right there, because it's somewhere on the negative side, right? Yes, and minus 2 over 3 is basically what? Minus 2 over 3 is minus 0, 0.666667, and somewhere here we have a minus 1. So it's before a minus 1. Then we have that point which is minus 2 over 3, which is 256 over 27. And then lastly, what do we need? we need the point of inflection. Remember, the point of inflection is where the graph changes concavity. So I can approximate it and say, yeah, it's somewhere there, right? Let's go and check the value. The value is a positive 1. It's 2 over 3, which is 0,667, and 128 over 27. So on the graph there I have it. It's 2 over 3 and 128 divided by 27. So that's the complete version of, or that's the graph, that's the sketch of the cubic function that we were speaking about. I hope this clarifies everything. Thank you.